Okay, section 1.5, we're going to talk a little bit about energy. We talk about energy in everyday life. Right? It's like, oh, I don't have enough energy, or I need to take an energy drink. I'm so tired. In science, energy has a very specific definition. It is the capacity to do work, which then we have to define what work is, right? So work is defined as the action of a force through a distance. So we have a picture here of a guy pushing a box across the floor. He is acting as a force on this box and causing it to move. That's work. It's nothing to do with getting paid. You pedal your bike across the street, you've done work. If you're walking, you're doing work. So those are the definitions of energy and work. There are different kinds of energy. The two main categories are kinetic energy and potential energy. So kinetic energy, as the word kinetic suggests, is energy associated with motion. So an object that is moving has kinetic energy. Potential energy is energy associated either with the position or the composition of the object. Here we have a picture of a 10-kilogram weight sitting on top of this brick building, and it's kind of teetering up there. That's not going to be a real stable position, right? Maybe a pigeon comes and lands on that and shifts the balance, and boo, it starts to fall, right? So as it's sitting up there, it has very little kinetic energy. It's not moving very much at all, right? Looks like it's not moving at all. As soon as it begins to fall, it's going to move faster and faster and faster. What's happening is that the potential energy that it had up here, being in an unstable position, that potential energy is decreasing as it gets closer and closer to the ground. The potential energy is being converted to kinetic energy as it goes faster and faster. And then when it hits the sidewalk, it stops. What happens to all that energy? Well, it gets converted into thermal energy, which you may or may not be able to detect just with your five senses. But when you have a collision like this, there's going to be heat generated. Essentially, all of the movement from this weight that's falling is going to cause movement in the cement. Not that it's going to be shooting down the road or anything, but it's going to cause a lot of vibrating and wobbling. So thermal energy is actually a type of kinetic energy, but it has to do with the motion of individual atoms. So we talked about the solid state of students on Monday and how, you're all stationary relative to each other, but you're not completely still, right? Some of you are more still than others, but everybody's still breathing. Yeah, it's good, right? So there's movement. If you were getting all antsy, like at the end of the lecture when I'm going overtime and I should have quit 10 minutes ago, and you're like, "Arr," and you're getting jittery, right? So you have more kinetic energy. When the temperature of a substance goes up, it's because the particles are more jittery. And so that's what's happening in the sidewalk here, is that thermal energy is causing all those particles to wiggle and the temperature goes up. So thermal energy is a kind of kinetic energy. It's associated with temperature. But the kinetic movement there is back and forth as opposed to through space. Any questions? Yeah.
Is there like an inverse relationship to those, or?
That's a good question. In this example, I'd say there's definitely an inverse relationship. As the potential energy decreases, the kinetic energy is increasing.
And is that just specific to this example, or is that in general?
I'd say it's in general, but there's many different types of energy. So the total amount of energy is conserved. So if one kind of energy is going down, one or more other kinds of energy has to be going up. Yeah, the only time energy is not conserved is in a nuclear reaction where mass and energy are converted into each other. But otherwise, the total amount of energy is constant. Good questions. Anybody else? which, here I got ahead of myself again. Happens a lot. I've seen these slides before. So the total energy is equal to the sum of the kinetic energy and the potential energy. And the law of conservation of energy says energy is neither created nor destroyed. So it can change from one form into another. Energy can flow from one object to another, but you can't create energy. You also can't destroy energy. Objects that have high potential energy tend to be unstable, like that weight sitting at the top of a building, right? It's unstable, you give it a nudge and it's going to fall. There are other forms of potential energy other than, position above the earth, but those positions are also unstable. So the chemical potential energy comes about not because, I lifted my calculator above the desk, but because there are charged particles within matter, and there are electrostatic forces that attract and repel those charged particles. And so the chemical potential energy comes from those electrostatic forces. Something that has high chemical potential energy like gasoline or TNT, something that, a spark and kaboom, right? That is unstable because of its electrostatic forces. And when given the opportunity, it will go to a lower energy state and release that energy, usually in the form of heat. So energy is always conserved in a physical change or a chemical change. The only place it isn't is in a nuclear change. We don't do that in Chem 1A, but I kind of feel like I have to tell you that because it's true. So systems with high potential energy are going to tend to change in a way that lowers their potential energy, and that energy then gets released into the surroundings. So here we have an illustration of a gas-powered car. So we have molecules in the gasoline that are unstable. They have a lot of chemical potential energy. And when these go into the engine and combust, that chemical potential energy turns into heat, and it also turns into kinetic energy of the car moving forward. So some of the energy of the gasoline causes the car to move forward, but some of it is just lost to the environment as heat. You probably know that your engine gets hot when it's running, right? What comes out of the exhaust is the leftover stuff from the gasoline, and this is going to be more stable because it has lower potential energy, because it lost most of its potential energy as the car went forward. Any questions?